First off, thanks everyone for joining us for BLS's first Discord community webcast. Today we're going to be going over a live demo of TrevorSpray, which has just recently had a bunch of updates worked on by Joel, aka our very own the Techromancer. In the demo, Joel's going to kind of walk through how the tool works, some of the neat things you can do with it, and what it looks like when it's actually running. So I'll hand it over to him, and I do ask if you guys have any questions, very much welcome them, but we will save any questions for the end, and I'd ask you to add them in text in the presentations questions thread within the Tool Talk channel. So if you have anything, throw it in there, and then we'll circle back to it at the end. All right, Joel, it's all yours.
Thanks, Sam. All right, so what I'm going to do is I'm going to start off just quickly talking about password spraying, and then we're going to talk about smart lockout, and then I'll go into Trevor Proxy and TrevorSpray and talk about them, and then we'll do some demos after that. So, all right, so I'm assuming that most everybody knows what password spraying is, but basically it involves guessing passwords. And basically what password spraying is you're looking at a company like Evil Corp, and you're asking like, okay, there's an employee at Evil Corp, say like Bob at evilcorp.com. You're asking, what's the chance? What's the statistical probability that Bob picked a password like a weak password like welcome123? If the chance of that is say like 0.1%, one in 1,000, right? Then if Evil Corp has 5,000 employees, then that means that if this chance is correct, 5 employees have the password of welcome123. And so basically, it's a statistics game, and what we find is that a lot of the time, almost all the time, at least one employee will have a common password. The usual example is, season, year, ! For example, winter 2021, bang. So that's usually the first one we try, and usually it works. So essentially, what you do is you gather a whole bunch of emails. So you have a list of 5,000, usernames or email addresses, and you take this one stupid password and you just try it with every single account. So that's the idea. The idea is that you by only trying one password for each account, you're not locking anybody out. You're not causing a lot of ruckus. You're basically just guessing one easy-weensy little password for each account, and eventually it's going to be correct. And it's a lot of fun. But recently, especially with the new cloud environments like Microsoft 365, Okta, Google, a lot of the ecosystems, you could say, they have countermeasures to prevent stuff like this, or at least to help prevent stuff like this. And so password spraying basically it is not near as much fun as it used to be, where you used to be able to gather that huge list and then just churn through them, really quickly, and immediately see, how many people were using that password. But along came a thing called smart lockout. And essentially what smart lockout is it takes the source IP address of the authentication attempt into account. So essentially, instead of just saying, okay, if this account has a failed login this many times, don't let it, lock it out. Don't let anybody else guess passwords on that account. But what smart lockout does is it's designed to not lock out the user, so that Bob, when some evil hacker on the internet starts guessing Bob's password, and failing over and over, it doesn't lock Bob out, it only locks the attacker out. And the way that they do that is they look at things like the source IP address. So what that means is that if you start guessing passwords, or start, trying welcome123 against all 5,000 of these employees, Smart Lockout is going to catch you and it's going to block you, even though you're only trying one password for each account. And I'll show that what that looks like. I showed it in the blog post, but essentially, this is what it looks like. So we'll wait for this to start over. So right here, I'm just guessing multiple passwords for the same account, but the same concept applies for multiple accounts. So as you can see, the orange ones are successful guesses. They're incorrect, but it's telling me, yeah, that password didn't work. And the reds are, nope, you can't do that anymore. It's locked. And so slowly but surely, Smart Lockout gets us to where we can't guess anymore. And it totally locks us out. But if you were to change your IP address, you could start all over, and you wouldn't be locked out at all. So essentially, that's kind of the problem that I set out to solve with TrevorProxy and TrevorSpray. So TrevorProxy, I'll start off talking about that because that's really the core of how we're able to get around this smart lockout problem. TrevorProxy essentially lets you randomize your source IP address or send your traffic from more than one IP address. And the way that works, there's a couple different ways that it does that. The first way is what I call a subnet proxy. And that's what you see in this diagram here. Essentially, how that works is if you have access to more than one public IP address, IPv4 or IPv6, you can tell TrevorProxy to basically listen or basically bind to that whole interface. And what it'll do is it'll spin up a SOCKS proxy, and any traffic that goes through that SOCKS proxy, it will assign a random source address from that subnet. So for example, if you have, say, if you're a lucky person and you have like a /24 block of public IPv4 addresses, you could use TrevorProxy to basically send your traffic from random addresses on that subnet. And essentially what that means is that, if you have 256 IP addresses, that means you can password spray 256 times faster, which is awesome. But, not everybody has access to those big blocks of IPv4 addresses because those are expensive. And also they're going extinct because IPv4 is running out, even though it's not really. Somehow we can still get them. Anyway, so you can also do it with IPv6. IPv6 addresses are super easy to get. Linode is one of the best cloud providers for that. They let you assign a /64 or a /56 for free, which is awesome, and it works great with TrevorProxy. So the other way that you can use TrevorProxy is with a SSH tunnel. So this is a cheaper and easier way than using a block of IP addresses. So in this, it's pretty simple. Essentially, it's also a SOCKS proxy, but it combines with SSH. So you just give it, the username and the IP address of a few systems that you own, say like, DigitalOcean, Droplets, or AWS virtual machines, whatever it is. And it'll actually open an SSH session to those systems, and then it will round robin all of your requests through those systems. And so it's pretty simple, really. It just uses SSH and IP tables to do that. Not really any complicated, firewall configurations or anything. This is sort of an alternative to something like Proxy Cannon, although it doesn't automatically provision these. So you do have to have them set up, and you have to have your SSH key copied to them already. So anyway, that's Trevor Proxy. TrevorSpray is a spraying tool that let's go back. TrevorSpray. Here we go. Okay, so yeah, TrevorSpray is a password spraying tool that has Trevor Proxy built into it. So the same sort of flags that you can add onto Trevor Proxy, you can use with TrevorSpray without running a separate instance. So it's all built in. So TrevorSpray, basically, it's been around for a little while, but I just recently updated it and added some new features. So now, since it used to only be a Microsoft Office 365 password sprayer, it now has other modules as well. I've written a few of them, and also it's totally modular, obviously. So custom modules are really easy to make. I have like a little example in the README. So if you need to spray a like a Palo Alto VPN or something like that, you can write your own module to do that. It's pretty easy. And TrevorSpray has a lot of features that are meant to bypass smart lockout in addition to the IP randomization. So it also has, you can add delays, you can add jitters, so it adds a random delay in between each request. You can add an additional delay if you encounter a lockout. It'll back off for a little while. All of these things help to essentially speed up your spray by ensuring that you don't get locked out and you can keep sort of rolling on. Okay, so other new features include the ability to operate over IPv6. So you can add a flag to the or an argument to TrevorSpray when you run it that basically says prefer IPv6, and it will always, anytime it resolves a host name, it will always prioritize IPv6. All right. And one of the biggest features that it has that I'm pretty proud of is these multi-factor authentication bypasses. So I added a whole bunch of MFA bypasses for Office 365. There are like 8 of them. And essentially what this is, it's a loot module. And just like you can write custom spray modules, you can also write a loot module so that when a valid credential is found, it will kick off a task. For example, pulling down all the contacts, like the global address list or something like that. So right now, the Office 365 module is the only one that has the loot module, but it will run these MFA bypass checks if it encounters a valid cred, and I'll demo that later. All right, and the last feature that I added was a recon feature. And essentially what this does is it allows you to specify a domain for recon, and it'll reach out to pull all of the MX records, the TXT records. It'll do auto discover. It'll pull the Office 365 tenant information and tell you like what the whether it's ADFS, whether it's federated, whether it's managed, and all that stuff. So just gives you some potentially useful information about the target. So all right, so let's go do some demos. So I'm gonna demo Trevor Proxy first, and then we'll move on to TrevorSpray. Okay. So first, what I'll do is I'll demo the SSH proxy. So what I'm doing here is I'm executing Trevor Proxy. I'm telling it D for debug, and then SSH, and then just giving it 2 hosts to SSH to. So I hit enter here, type in my SSH key password. All right. So what it did is it SSH'd to both of those hosts, added a couple IP tables rules, and now it's listening. So now what I can do is if I do a curl, I'm just doing like a curl ifconfig.me. This is just a service that, when you go to it in your web browser or you make a web request to it, it just tells you what IP address you're coming from. But I'm sending it through the SOCKS proxy. which is Trevor proxy. So you can see that when I did that, the IP address that it's returning is this host right here, the .206. And if I do it again, it's this one. So what it does is it's just round robining between them. So I can keep doing this, and you can see that it's evenly spreading out the requests between those two different IP addresses. And you can add as many as you want. If you do this exact same thing with TrevorSpray, it will also use your current IP address, which you can disable if you don't want that. But that's really nice if you have 4 SSH systems on the internet, which isn't a whole lot, and you use your current IP address too. That's 5 times the speed. You can spray 5 times as fast. So that's Trevor proxy with the SSH proxy enabled. So next, I'm going to do Trevor proxy with the subnet proxy. So what I have here on the bottom is I have a this is a Linode VM, and I have basically a /56 IPv6 range assigned to this VM. So when I tell Trevor proxy to start a subnet proxy on that subnet, basically what it's going to do is it's going to do the same thing as it did with the SSH, where it's going to basically randomize the source address. So I'm going to do the same thing as I did before, except when I'm doing the curl, I'm going to basically do tax6 for IPv6, and then I'm going to use this service, which is the same thing as I've configured on me, but it's just for IPv6. So you see when I did that, Trevor proxy showed that it basically accepted a connection, and it generated a random source address. And this random source address that it generated right here, ending in C5E9, is what this service is telling me I'm coming from. And this is actually really nice if the service that you're attacking supports IPv6, because man, like this is a lot of IP addresses. Like the amount of unique IP addresses that you can generate with even like a /64 is just absolutely astronomical. We can even calculate it. So a normal IPv4 address has 32 bits, which is about 4 billion possible addresses, right? That's the entire internet. Like that's the entire IPv4 internet, 4 billion. But with IPv6, let's just like calculate it here. So with IPv6, instead of 32 bits, you have 128. So if you have a /56 range, which is free on Linode, then that's this many IP addresses, which is a lot. If you want to look at like how many commas it has, it's that many commas. I'm actually curious. That's 7 commas. So anyway, it's a lot of IP addresses. I think that's a sextillion. That's 4 sextillion IP addresses that you can come from. So, good luck blocking. Good luck blocking it at that point. So anyway, like I said, these 2 features are built into TrevorSpray. But if you don't like using TrevorSpray and you want to use something else, or you just want to use Burp, or even like your web browser, you can absolutely do that. Just spin up Trevor proxy and set your proxy to that. All right. So next, we're gonna look at TrevorSpray. So since I already demoed the proxy features for TrevorSpray, I'm just gonna focus on the MFA bypasses, which is probably the biggest new feature that I've added. So what I'm doing is I'm gonna execute TrevorSpray. I'm gonna say for usernames, go and pull the usernames out of this emails file, and then give it a password. And I'm gonna say when you encounter a valid cred, go ahead and exit. You can stop guessing at that point. And I'm going to disable loop modules at first, just so you can sort of see how it works. So this. Okay. So essentially, it gets some usernames. None of these users exist because they're fake. I made them up. But then it got a successful one. So here it is. And basically what you can see is, even though it succeeded, the response indicates that multi-factor authentication is in use. So if I were to take this account and go to portal.office.com, type in the email password, it would say, oh, like, what's your token? And I wouldn't be able to log in unless I somehow was able to social engineer that token from the user. Which is a bit of a problem. Sometimes you can do that, but sometimes you can't, and it can be really annoying. Two-factor is one of the biggest, I guess, hurdles or blocks, for us on external engagement. Really messes with us. So anyway, thankfully, Microsoft has a whole bunch of legacy protocols that don't even know what two-factor is, which means they can't work with them. So essentially, what I'm going to do next. Well, first I'll show how everything that happens here is logged and recorded. So nothing is lost. So everything gets when you run TrevorSpray, everything gets logged to the home .TrevorSpray directory. So if I list that, you can see that there's these 4 text files. What I'm going to do is I'm just going to show you what's inside those really quick. So inside the existent users, this file keeps track of which users exist, which ones are valid, even though the password wasn't valid, or whether or not the password was valid. It'll put them in here. So this is useful if you have a ton of emails and some of them aren't valid. Maybe you just you scraped LinkedIn and just like generated email addresses for a whole bunch of names. You're not really sure whether or not they actually work there, but you're going to try them anyway. After the first run, it will put all of the valid accounts in this file, and from then on, you can just use this file as like your usernames file. That way you won't waste time trying the ones that don't exist. All right. The tried logins, this file basically just remembers all of the passwords that you've tried. So that way you can easily stop and resume if you need to, and it will never guess the same password twice. So you don't have to worry about shuffling your file or keeping track of where you were when your internet went down and everything. So it'll automatically skip these if we did it again. All right, and then finally, the valid logins. This just records, when you get a valid cred, it'll record what the email and password is for that, because you don't want to forget that. All right, so what I'm going to do is I'm just going to remove that whole directory for now, just so we can start over. All right, so this time I'm going to do the same thing, but I'm going to run the loop module. And so, remember that this account has multi-factor authentication enabled, and we're basically just going to see what different ways we can bypass that MFA. Okay, so you can see once we got the valid cred, it kicked off the loop module. I'm actually a little bit surprised because IMAP was enabled for it this morning. I don't know what happened. I didn't change anything. All right. Okay, so it's finding some stuff. Okay, great. Okay. So I should just start by saying that when it comes to MFA bypasses, it is immensely confusing. I'm not not necessarily to exploit these, but just to comprehend the configuration behind it all. It's complicated for attackers, and it's even more complicated for sysadmins. So, I mean, I wrestled with Microsoft 365 for probably a day, just trying to figure out like what settings I can change that will actually even affect these configurations. But essentially, uh, if you were to create a new Office 365 tenant today, most of these would be disabled by default. But and you can enable them, but it's more difficult than it used to be. But the thing is, for older tenants, for companies that have been around for a long time, it's very likely that you will find one of these enabled. Just because of all the grandfathering and sort of the configurations that have filtered down from a long time ago. They're still around. So I'll go through from the top and just sort of show what kind of checks it did. So found a valid cred. The first check that it did was it checked IMAP, which is it's an email protocol. You might have used IMAP before. It's not a Microsoft thing. It's been around for a long time. That failed. So the next thing is it tried SMTP. So IMAP is a receiving protocol. SMTP is a sending protocol. So both of those failed. Next, it tried POP3. POP3 is a lot like IMAP, except it's crappier, but it's the same sort of concept. If you have access to POP3, you can check the victim's email. And POP3 was enabled, which is great. Okay, so now you can basically download all of their emails without two-factor. Okay, so the next thing it checked is Exchange Web Services, EWS, and that worked. And so what TrevorSpray did was it went ahead and it used that MFA bypass to dump the global address list. And so now if you look in TrevorSpray, in the loot folder, you'll see that there's this .csv file. So that's just a CSV with all the contacts in the organization. So, for example, if you're having a lot of trouble with OSINT, and you aren't really able to enumerate all of the employees, if you're able to just get one valid cred with an MFA bypass, there's a high likelihood that you'll be able to pull their entire address list and do another spray. With every user in the organization, you'll have a much better chance of getting some more valid creds. Great. Okay, so Exchange Web Services got us their global address list. The next thing that it tried is ActiveSync. ActiveSync is a very old proprietary Microsoft protocol that I think actually enables sending and receiving of emails if you can find an email client that's old enough to support it. I actually think that Windows 10 has I think the Windows 10 Mail app has a built-in ActiveSync client. So if you can trick that client into not using the modern authentication and falling back to the legacy ActiveSync stuff, that would work. So this would probably allow you to both send and receive emails as that user, as well as pull down their contacts. So yeah, ActiveSync supports contacts. So you could search their inbox. You could pull their contacts with that method as well. All right, Exchange Online PowerShell also enabled. So you could probably read their emails with that too. And also if they're a member if they're a member of any shared mailboxes, you could also read those. All right. So the final bypass that worked is AutoDiscover. And TrevorSpray, when it encounters this, it will go ahead and just print the AutoDiscover information. And there's some useful information in here, like what different URLs they use for ActiveSync, for web services, for ECP, which I don't even remember what that is. But basically, there's just endpoints for a whole bunch of stuff. If they're a big company and they have sort of a hybrid environment where they have some things on-prem, some things in the cloud. Maybe they have ADFS. You'll see a lot of differing URLs here instead of just Office 365. But anyway, so TrevorSpray will parse this, and it will go through and it will look at all these URLs, and it will pull out the interesting ones, and it will try some additional MFA bypasses on those. All right, so if auto-discover is enabled, it'll go and it'll look for the OAB URL. OAB stands for offline address book, which is sort of a old way of syncing contacts to Exchange. So it was able to find an OAB URL. So then what it does is it goes and it starts downloading anything that's associated with that offline address book. Sometimes there can be more than one. So if that's the case, it'll pull all of them. But in this case, it found an LZX file. This is all just like sort of legacy Microsoft stuff. LZX is a compression algorithm that's like super old. It's what they used for like the .cab files way back in the day. So anyway, there's a tutorial on the README on how to actually extract the data from these, and it has some interesting data. It's a lot like the global address list, except it also has some interesting LDAP goodies in there as well. All right, so that's pretty much it. So essentially, TrevorSpray found a valid cred, and even though MFA was enabled, it was able to essentially get us the capability to not only send and receive emails, but also pull all of the contacts from the organization in two different ways. We could do that two different ways. So, yeah, long live legacy protocols. All right, that's pretty much all I had. I think Sam, now we can go on to questions.
Yeah. First off, thanks, Joel. Really appreciate you running through that. It's such an awesome tool. Super impressed with what you've managed to do. But yeah, if anyone has any questions in the audience, don't hesitate to throw them into the questions thread that we have in the Tool Talk channel. I know, went through a lot, so don't hesitate to ask anything that may have come up while going through that. Or if you just want to say anything at all, that's fine too. I think majority of folks on here are BLS folks, so I know you guys have already gotten a sneak peek at the tool as it is. So
go download it, go try it out. It's a fun time.
Absolutely. All right. Well, not a ton of questions, so we'll maybe one. No question. But thank you, Jack. We're excited for you to play with this as well. All right, so I'll go ahead and wrap it up here. So a couple things before for people head out. Big thanks to Joel for doing this. Live demos are always I'll say exciting. So thanks for putting yourself out there and putting yourself out here for this. This was our first attempt at one of these sort of webcasts. We are looking at opportunities to do more of them and other community related activities throughout the coming year. So keep an eye on all of our social and here within the Discord itself for any of those upcoming events as we're coming out with them. The podcast will also probably be a less time-friendly way to hear about them, but we will probably talk about them there as well. If any of you guys have questions or want to get in contact with us, Discord is probably the fastest way, but I know a lot of us have various ways to reach us. A lot of us that have public usernames and want to be chatted with, reach out to us. And on that, just thanks everyone for taking your lunch break or your time here to sit in with us and listen to our tool and try it out. Give us some feedback and let us know what other kind of problems we can try and fix. Thanks everyone.
Thanks, Sam.